Yes, good morning, students. Today we are going to see a topic called Pearson coefficient of skewness. First, we will see the formula. How to calculate call Pearson coefficient of skewness. This is the formula. Coefficient of skewness is equal to mean minus mode divided by standard deviation. Okay. Yes. If the given data are individual observation, then how to calculate mean, mode and standard deviation. So this is the formula for calculating mean. Mean is equal to summation x divided by n. Mode is obtained by the data which is repeated for maximum number of time. Then standard deviation. Sigma is calculated with the help of square root of summation x minus x bar whole square divided by n. If the given data are discrete data, then how to calculate mean, mode and standard deviation. So this is the formula. X bar is calculated with the help of summation fx divided by sum f, and mode is obtained by the value which corresponds to the largest frequency, and standard deviation sigma is equal to summation f into x minus x bar whole square divided by summation f. Then if the given data are continuous, then this is the way we have to calculate mean. Mean is equal to summation fm divided by f, where m represents midpoint of the given class interval, and mode is obtained with the help of this formula. Mode is equal to L plus f1 minus f0 divided by 2 times f1 minus f0 minus f2 into I. Here L represents lower limit of the modal class, f1 represents frequency of the modal class, f0 represents preceding frequency of the modal class, and f2 represents succeeding frequency of the modal class, and I represents length of the modal class or size of the modal class. Then finally standard deviation is obtained by using this formula, square root of summation f into m minus x bar whole square divided by summation f. Here m is nothing but what? Mid value of the given class interval. Yes. Next we are going to see one numeric example for this problem. Yes. Find the Pearson coefficient of skewness for the following frequency distribution. Annual sales and number of items is given. For 5 it is given as 2, for 10 it is given as 8, for 15 it is given as 22. So for each and every annual sales we are having number of items. So that means it comes under discrete data. We have to take annual sales as an x and a number of items as an f. Next, first we write the formula. We know that coefficient of skewness is equal to mean minus mode divided by standard deviation. Yes. So for discrete case, the mean is obtained with the help of summation fx divided by sum f. For standard deviation, square root of summation f into x minus x bar whole square divided by sum f. Yes. So here we have to find the value for f into x, then x minus x bar, then you have to find the square, then that will be multiplied with sum f. So based on this we frame the tabular column. First x f, then fx, multiplication of these two things, then x minus x bar, then you have to square this, then you have to multiply this with the frequency. Okay. Next we will write the values of x one by one. 5, then 10, then 15, then 20, then 25, then 30. So next we have to write the frequencies one by one. 2, 8, 22, then 34, then 16, then 10. Okay. Then we have to multiply what fx means. We have to multiply these two values, so x into f. So 5 into it is 10, so 10 into 8 it is 18. Likewise we have to multiply the subsequent values is to get the values of fx. Okay, after that you have to sum the value of f. When you add up all the values of f, which is nothing but 92, which is nothing but sum f. Likewise, we have to do it for fx. If you add all the values of fx, which is nothing but 1800, which is sum fx. Now substitute these two values in the mean formula to get the value of x bar. So mean is equal to 1800 divided by 92. When you simplify, you are getting it as 19.57. Then what we have to do? We have to subtract mean with each and every values of x. So 5 minus 19.57 gives what? Minus 14. Likewise, then 10 minus 19.57, you are getting it as 9 point. Likewise, you have to do it for, you have to calculate for the remainings. Okay, yes. Then you have to square these values. So x minus x bar whole square. When you square this value, minus will becomes plus. So 14.57 square is 12.28. Then minus 9.5 square is 91 point. Likewise, you have to square the successive values as. Okay. Then you have to multiply x minus x bar whole square with what? F to get this one. So 2 into 212.28, or getting it as 424.56. Then 732.64. then 22 into this one, or getting it as 459.36. Likewise, you have to calculate the remaining values as. After finding that, you have to find the sum value of x minus x bar the whole square. Yes, now when you add up all the values, you are getting it as 3182.16. Now substitute this and this in the respective formula to obtain standard deviation. So SD is equal to square root of, we obtain sum f of x minus x bar whole square as 3182.16 divided by sum f. Sum f is 92. Yes, now you divide these two things and take square root now, which is nothing but standard deviation. We obtain standard deviation as what? 5.88. Next we have to calculate mode. For finding mode, you have to see the frequency. Which one is the highest value? 34 is the highest value. The next highest value is what? 22. Now find the difference between these two things. If it is greater than 3, we can find mode directly, or else we have to go mode with the help of empirical formula. Here the difference is greater than 3. Therefore, mode is obtained by direct method. So corresponding x value of the highest frequency is what? 20. Therefore, we can call mode as what? 20. Okay. Then substitute these three values. After finding mean, standard deviation, mode, substitute all these values in the formula to get coefficient of skewness. Yes. Now coefficient of skewness is equal to 19.57 minus 20 divided by 5.8. If you simplify, you are getting it as minus 0.07. Yes. Next, another numerical example for Pearson coefficient of skewness for continuous case. See here, annual sales and number of items. And previously we did the problem for discrete case. Now we are going to discuss the same measure for continuous case. Okay. Yes. First we will write the formula. Coefficient of skewness, we know, mean minus mode divided by standard deviation. Then write the formula to calculate mean for continuous case. Mean is equal to summation fm divided by sum of. Mean standard deviation is equal to square root of summation f into m minus x bar whole square divided by sum of. So using this we can calculate the tabular column. Yes. Consider annual sales as class interval, number of items as f. Then we have to find the value for m. m is nothing but what? Middle value of the given class interval. Then fm. So you have to multiply these two things, and then we have to find the value for m minus x bar. So then we introduced m minus x bar, then we have to square it. Then we have to multiply m minus x bar whole square with f to get the numerator of what? Standard deviation. Yes. After framing this, write the class intervals one by one, which is given in the problem. 0 to 20, then 20 to 40, then 40 to 60, then 60 to 80, then 80 to 100, then 100 to 120. Then write the respective frequencies one by one. 20, 50, 59, then 30, then 25, then 16. Yes. Next we have to find the value for m. How to find the value for m? Which is nothing but adding lower limit and upper limit of the given class interval, then divided by 2 gives what? Mid values. So 0 plus 20 is equal to 20. 20 divided by 2 is equal to what? 10. Like so now we obtained it. Next, likewise we have to do the same thing. 20 to 40. 20 to 40 is what? 60. 60 divided by 2 is equal to what? 30. Likewise we have to find the remaining middle value for the respective class intervals. So 50, 70, 90 and 110. After finding that, we have to find the value for fm. So multiply these two things. 20 into 10 is 200. Likewise 50 into 300 is 1500. Then 59 into 50 is 2950. Likewise calculate the remaining one. Then we have to calculate mean. For that we need the value for sum f and sum fm. So sum f is 200. When you add up all the values of frequency, which is giving us 200. When you add up all the values of fm, which gives us what? 10,760. Now substitute these two values in this formula to get mean. When you divide these two things, you are getting it as 53.8. Next, what we have to do? We have to find the value for m minus x bar. How to find m minus x bar? By subtracting 53.8 with each and every values of the mid values, each and every values of m. Then 10 minus 53.8 is minus 48. Likewise go for the next one. So 30 minus 53.8 is 23.8. Then minus 3.8. Likewise calculate the remaining one. Then you have to square these values. When you square this value, now minus will becomes what? Plus. So 43.8 square is what? 1918.4. Then 20 minus 23.8 is 566.44. Likewise calculate the remaining one. Then you have to multiply m minus x bar with the f, that is given frequency. So 20 into 1918.44 is what? 38,368.8. Likewise calculate the remaining values as. Then finally we have to add up all the values as to summation f into m minus x bar whole square, just nothing but this one. Okay. Yes, after finding that, substitute the respective values in standard deviation SD formula to get what? Standard deviation. Yes. Now when you substitute these two values in that formula, simplify, you are getting standard deviation as what? 28. Next you have to find mode. For finding mode, first we have to see the frequency. In frequency, highest value is what? 58. The next highest value is what? 50. Difference between those two things is greater than 3. So therefore we can calculate mode using direct formula, which is nothing but L plus f1 minus f0 divided by 2 times f1 minus f0 minus f2 into I. So Highest frequency we call it as F1. Above highest frequency we call it as F0. Below F1 we call it as F2. Okay, then class interval which is correspondence to F1 is called as model class. Okay, 40 to 60. Now here L represents lower limit of the model class. Lower limit of the model class is what? 40. Yes, now replace L with 40, F1 with 59, F0 with 50, F2 with 30, and I is nothing but what? Difference in the class interval. Difference in the class interval is what? 40 to 60 is what? 20, which is nothing but I. Now substitute all such things and simplify. You are getting the value of mode as what? 44.74. Then substitute these three values in that respective formula to obtain coefficient of skewness. Coefficient of skewness is equal to 53.8 minus 44.74 divided by 28.17 is 0.32. Okay, hope you can understand this two examples and how to calculate coefficient of skewness. Thank you. In next video we will see another measure which is related to this portion.